Kia ora everyone doing AS from Wellington College. This video is going through questions 6 and 7 of the March 2020 stats paper. Now question 6 is a pretty straightforward probability tree one, but what I really want almost all of you to watch is the second one, which is a cumulative frequency graph with a bunch of questions. So I didn't mark your papers, but I suspect that this question was pretty badly done because there's a lot of fiddly detail to get these right. And the last part where we have to calculate an estimate for the variance of the lengths of the fish is something that I'm going to go through really, really slowly. But first up, let's get this pretty easy probability tree diagram thing done. I talked about this at the end of the last video a wee bit, but what we've got is we've got two boxes and we've got red and blue balls in each box. Box A has got 7 red ones and 1 blue ball, and then box B starts off with 9 red and 5 blue. And then a ball gets picked from box A and it gets stuck into box B. So what we're going to have in the first bunch of the tree is we're going to have a number out of 8 because we've got 7 red and 1 blue ball. So we'll put those onto our tree first. So 7 out of 8 here and 1 out of 8 here. Now in box B we start off with 14 balls, but 1 gets added in. So my denominator here will be out of 15, but it's going to depend on what happened in stage 1. So if the first one chosen was red, that means that we now have 10 red and 5 blue. But if the first one chosen was blue, I really should not be using a blue pen here because it's going to confuse all of you. We will have 9 red and 6 blue. And that's about all there is to this question, right? So here it will be 10 red out of 15, 5 out of 15. Don't worry about simplifying those fractions. And here 9 fifteenths here and 6 fifteenths down here. Now I've just realized I've only transferred the first part of that question. There are a couple more parts, so I'm just going to pause the video and pop those questions into the file here. Okay, so you can see the actual exam paper here. The second question is just to find the probability that the two chosen are not the same color. So hopping back over to OneNote, not the same color means I'm either going to have red blue or blue then red. So I have your tree diagram in front of you to answer this, but it's the probability of RB plus the probability of blue then red. So red then blue is reading off the tree. We get this, we get 7/8 times 5/15. And then blue then red is 1/8 times 9/15. So getting a common denominator of 120, I get 35 plus 9, which gives me 44. You get a tick for that. You don't have to simplify that, but it looks pretty bad to me unsimplified. So dividing both by 4, we get 11/30. That's that one done. Okay, then the next question was a conditional probability one. So given that the ball we chose from box B is blue, what's the probability that the ball chosen from box A is also blue? So conditional probability is a really, really useful idea in probability, and we're going to write it using this notation here. So it's the probability that A is blue given that B is blue. And that's equal to the probability of both of those things happening, that A and B are both blue, divided by the probability that B is blue. So what we're intuitively doing there is we're limiting our you can think of it just about as like a sample, where you're limiting yourselves to all of the situations where B is blue, and you're saying, well, when B is blue, when is A also blue? And this formula is, I'm pretty sure this is given on the probability on the formula sheet, but in general, the probability of A given that B happens is this. And you'll use that over and over. That's something that you should basically know. This horseshoe sign here means A and B. Right, and if you don't use that much this year, you will definitely use it if you're doing level 3 stats later on and at uni. Okay, so the probability that B is blue, well, that can happen in 2 ways. It can be red-blue or blue-blue. So that's 1/8 times 6/15 plus 7/8 times 5/15. So you'll see that not simplifying the fractions does help me quite a lot. And then in the numerator, we've got just one of those, A and B both being blue. Right, so that's that one there, that's A and B both blue, and that one there is the red-blue. Now notice that I've got the same denominator in all of those fractions, so I can just, in my head, times by that, and that gives us 6 over 6 plus 35, which gives me a final answer of 6 out of 41. Okay, so that was the first part of the video, and that was the short part. I'm probably going to spend about 10 minutes now on question 7, because, as I said, this is often really, really badly done, especially by people who are redoing AS and haven't looked at this kind of basic data interpretation stuff for about a year. So Helen has measured the lengths of 150 fish of a certain species in a large pond, and these, correct to the nearest centimetre, are summarised in the following table. So what we've got to think about here is that these lengths have been rounded, but actually the lengths, like in here it says 0 to 9, but that class is really going from 0 higher than 9, right? In this class of 10, you can think of fish lengths. Well, they're continuous, right? So yes, they're going to start at 0, but the category that's called 0 to 9, what are we doing with these fish that are between 9 and 10? Well, they're going to be rounded down if they're below 9.5, and they're going to be rounded up from 9.5 up. So the first thing to kind of deal with a problem with a cumulative frequency is to think about what are these class boundaries, because later on down here we're going to need to be careful to get the midpoint of each class boundary. So I'm going to start by just writing those out now. So let's do a new table, because when we go to do the cumulative frequency graph, it's going to help enormously if we've got the class boundaries right. So the 0 to 9 is actually from 0 to 9.5, and that's got 15 fish. The next one has got fish between 9.5 and 14.5 centimetres in it, and there are 48 fish in there. The next one goes from 14.5 up to 19.5, and there are 66 fish, and the last one goes from 19.5 up to 30.5. and there are 21 fish in there. Now, we don't know exactly where in these categories the fish are measuring, but we're assuming that they are roughly evenly distributed. But when we do a cumulative frequency curve, we are drawing a curve, right? We're not just going to end up going, I've seen some people do it like this with just a series of straight lines. We're really trying to fit a curve through some endpoints. So I recommend that you do it in pencil and then you go over it in black pen. Remember, you're not meant to use blue pen for these exams. While I'm here, and because I know that I'm going to be doing it when I'm estimating the variance, I'm going to get the midpoint of each of those 4 classes. Right, so you can grab your calculator to do this, but that first one is going to have a midpoint of 4.75. The next one, I got a midpoint of 12, I think. Just let me check. Where's it gone? Yep, midpoint of 12. The next one's got a midpoint of 17. And the last one's got a midpoint of 25. I'm just going to check that those numbers are. Okay, so I've checked, and those midpoints are the ones that I want to be using, right? But we're going to do that at the end. We're going to work out an estimate for the variance of the fish. The first thing we're asked to do, and it's for quite a lot of marks, it's 4 marks, we have to draw a cumulative frequency graph to illustrate the data. So things we've got to think about, we've got to label the axes, we've got to choose a scale, we're going to use pencil first, and then we're going to remember that we're drawing a curve, not a line. The first thing to do, I think, is to put down the coordinates of the points that you're going to put onto your big graph. And that is going to help us choose our scale. So the first point is going to be at the start. Point 1 is going to be at 0, and there are 0 fish there. Right, and these axes are going to show me the length. So the x coordinate is going to be the length in centimetres, and then the y-axis is going to show me the cumulative frequency. In other words, how many fish are below that height. Right, so here it's going to be 15. Here I'm going to add the 15 and 48, and I'll get 63. And then adding another 66 gives me 129. And lastly, we should end up with 150, right? Because we were told that's how many fish. So I need to have the up the side going up to 150. And here I need to be going up to at least 30. So we're going to take our ruler. I'm going to try and do this accurately. And this is fiddly, so I want you to see just how fiddly it is. Let's do, what are we going to do for a scale? Well, let's put my ruler in here like this, and then roll up the next one, and do your labels. I'm going to pause so you don't have to watch me doing that. Okay, I want to talk even now about the scale here. You can see that I've actually screwed it up by not starting low enough down, right? I need to be getting up to 150 fish, and I've done a nice big scale. I think I've got it right, although I've got tired older person eyes, and so I actually can't tell. Now, the first thing that I'm doing that's bad on here, that I don't want you guys to do if you get this in the exam, is that you can see that the scales had to go all the way up there past there. Now, we can get away with that, but it's not ideal. The second thing is I definitely shouldn't have these numbers on this side. I should have these numbers over here, which means that that label that says cumulative frequency really should go away, right? So we're going to put these numbers not on here, but up the side. Now, you're probably going, why is she spending so long telling us this? Well, it's because these questions, you can just get 4 out of 4 if you do it right. So you just have to learn how to do it. So I want you to have seen me doing it wrong. Okay, so that's my argument, and I'm sticking to it. So there we go. We've got 20, 40, 60, 80, 100. I've lost my 120 somewhere along the way. I think it's there, right? So this is the fiddliest thing you're going to have to do in this exam. And then we've got to put on the points. So to put on the points, we're going to go back and use our table. So what points go on? Well, the first point's going to be at 0, 0. We've done that one. But the next one is not going to be at 9, and it's not going to be at 10. It's going to be at 9.5. And there will be, so up to 9.5, there'll be 15 fish, right? And then up to 14.5, there will be 63 fish, and so on. So the points we're plotting are these. So 19.5, 129 fish, and then 30.5 and 150 fish. So let's try and do that quickly now. So 9.5 and 15, I'm going to have to put some lines on here. 2, 4, 6, 8, 10. All right, so this is really hard to do. So this is why you take a ruler in 2, 4, 6, 8, 20, 2, 4, 6, 8, 30, 30 here. Now, that's not a great scale, but it'll do, right? So 0 and 0, we put that mark there, and then we make it really obvious where the next one is. So 9.5 and 15 goes up here. Right, so that's my first dot. My next one goes at 14.5, so not quite here, and it goes up to 63. I'm going to take a ruler to do that, and I recommend that you do that when you're in the exam. So 14.5 is out here. And I can hear some of you going, why on earth do we have to do this, miss? Because we would use a computer to do this. So I have some sympathy for that argument. But right now, we're just trying to pass an exam. So let's put it on. So 63, I think, is there, right? But I don't want this video to go on all night, so we're going to put it there and get on with it. So there's 63, and then what's next? 19.5 and 129. So it's up here. And again, we need a ruler. 19.5 is here, 129. So it's very steep up here. So I haven't got these quite right, guys, but I actually can't see very well right now. So there we are. And then the last one's at 30.5 and 150. So what we're starting to see, there's a pattern in the curve. So we're seeing the curve slacken off a bit. Right? And if you've got this, the marker can see that you actually know what you're doing with these curves. Now we're going to join it up. Now this is going to be fun. We're going to try and do it with a curve. Oh man, this is why you use a pencil, guys, because that just looks terrible. It looks like, I don't know what it looks like I've been doing, but there, it's a very bad curve. Okay, don't do it like that. Do not do what I've done there, right? So if you're stuck with it like that, just maybe try rulering it. Go really slowly, like that. The curve should not be going backwards, right? But that's because my hand is shaking with the stylus. There. So that's what the cumulative frequency curve should look like. Now you can see again, I've used the wrong scale, right? If I'd used the whole width, it just would have looked so much better. What do I have to do with it now that I've finally drawn it? Well, we have to go, 40% of these fish have a length of D centimeters or more. So use your graph to estimate the value of D. So 40% have a length of D or more. That means 60% below D. And that's what we want. And that's what the question is testing that we know. So 60%, 0.6 of my